In this video, we will be discussing about the nomenclature of carboxylic acids. In order to do so, we should first know that what are the carboxylic acids. These are the organic compounds that contain the carboxylic group. This group is so named carboxyl group because it has a carbonyl carbon and a hydroxyl group attached. When these both groups are attached, that group is then known as the carboxyl group. So whenever we have to name the carboxylic acids, we should start the naming from this carbonyl carbon atom. The naming goes the same as it goes for the alkanes or alkynes, that we first select the long carbon chain. That is, this is the longest carbon chain over here, the only, you can say, carbon chain over here. And here the naming will start from the carbonyl carbon atom, or we can say from the carboxylic group. The numbering will start from here. As we have here, this is carbon number 1, carbon number 2, carbon number 3, and carbon number 4. We are having 4 carbon atoms over here. These 4 carbon atoms represent the butane, but in case of naming of alkene, we name it as butane. But here, this is a carboxylic group attached. So in order to name the carboxylic acid or this carboxylic group, we will replace this E by the suffix oic acid. As you can see over here, this butane is now named as butaneoic acid, or we can say it as butanoic acid. Next, coming toward another example, here, if there is a substituent attached, as you can see from there was a hydrogen. This hydrogen is now replaced by a methyl group. So now how we will name that? We will simply do as that we do for alkane, alkene, or alkynes. We will just simply name the first we'll name the longest carbon chain, that is 1, 2, 3, and 4. Now we see that this substituent is attached on the carbon number 3. So we'll write it as 3 and then the name of the substituent, that was methyl group. We'll name it as 3-methyl. And then we have 4 carbon atoms. We name it as butane and then oic acid because it is a carboxylic group is attached over here. Now, coming to another example, if there is a compound which is having a substituent, but also there is a double bond present in them. So how will we name that? The same goes for here. We'll select the longest carbon chain, number them from starting from the carboxylic group 1, 2, 3, 4. Now here we'll first note that there is a substituent attached. This substituent will be named first like 3-methyl. Then we'll see that where is that double bond present. The double bond is present on carbon number 3. We will write it as 3. But here in this case this is a butene because here is a double bond. And now here the E of the butene will be replaced by oic acid, so it will become butanoic acid instead of butanoic acid. A is replaced by E because of that double bond. Here we have 4 carbon atoms, but I have not numbered this one carbon atom because this is acting as a substituent. We don't number a substituent while numbering the long chains of carboxylic acid. For example, if this oxygen is not present over here, and instead there is a carbon atom present, then this carbon atom will be numbered as 5 and this will be numbered as 6. But as you can see over here, but this is not a carbon atom, instead this is an oxygen. So this whole will be known as a methoxy and we will name it as 4-methoxy. Why 4-methoxy? Because methoxy is present on carbon number 4. And why we haven't started the numbering from here? Because we always start the numbering from the carboxylic group. And here is a carboxylic group. So we'll number it from here 1, 2, 3, 4. And on the 4 there is the methoxy group present. So we'll name it as 4-methoxy. And why butanoic acid? Because 4 carbon atoms are present. So we'll name it as butanoic acid. Hope it is clear. And this is a very easy example. It might look complex or difficult, but actually it is a very simple example. Here we have 1 carbon atom, we'll number it 1 from the carboxyl group, then 2 over here. Now we have 2 long chains. We have to select one of them. So we'll always select the chain which has the more number of carbon atoms. But in this case, we have 3 carbon atoms over there up above and 3 carbon atoms there. we can select any of them because they both have three carbon atoms. Three carbon atoms, three carbon atoms. They both have the double bond on the same position of carbon atoms, so we can select any of them. Let me select the four upper one. Here it is carbon number 1, carbon number 2, 3, 4, and 5. If we'll name this specific carbon chain, we'll name it as pentenoic acid. Why pentenoic acid? Because there's a double bond present. And where is the double bond present? Double bond is present at carbon number 4. So we named it as 4-pentenoic acid. Now what is 2-allyl? Some might think that it might also be called as propene, but here it is not a propene, because if it would be a propene there would be CH3, but it is not a propene over here. We'll name it as there is a specific name for this compound, which is allyl. You can see from here that it is present on carbon number 2, so we'll name it as 2-allyl 4-pentenoic acid. Next, coming to a different thing, that is a benzoic acid. Whenever one hydrogen of benzene is replaced by a carboxylic group, we named it as benzenoic acid. Okay, so there might be any substituent attached to the benzene. So whenever there is a substituent attached, we'll do the same thing. Okay, now here it is carbon number 1. Starting from here, it will be the carbon number 1, carbon number 2, carbon number 3, and this will be carbon number 4. Now here we see that the sulfur group is present over carbon number 4. We'll name it as 4-sulfur. And the rest, this whole thing, is the benzoic acid, as you can see up there. Whole thing is the benzoic acid. So we'll name it as 4-sulfur benzoic acid. Now, there is another classification of carboxylic acids, that these carboxylic acids are of three main kinds, that is monocarboxylic acids, dicarboxylic acids, and tricarboxylic acids. The ones we have did earlier were the monocarboxylic acids. Dicarboxylic acids are those kind of carboxylic acids in which there are two carboxylic groups present on the ends of the long carbon chain. Here we can name it as we know, numbering will always start from the carboxyl group, either from here or either from there. We'll number it as 1, 2, 3, 4, 5. 5 carbon atoms, so we'll name it as pentane. But as we did earlier, where E was replaced by oic acid, here in this case, E will not be replaced by the oic acid. Instead, we will write the whole pentane and it will be named as dioic acid because there are two carboxylic acids present. Next, in the case of tricarboxylic acid, the naming is a bit different from monocarboxylic acids. Here, we'll take these carboxylic acids as a substituent and number only the long carbon chain. Starting from here, 1, 2, 3, 4. We have 4 carbon atoms. We'll name it as pure butane. Remember, E is not replaced by the oic acid as we did in the monocarboxylic acids. Instead, we'll write the full butane. And we know that there are 3 carboxylic acids present over here, so we'll name them as tricarboxylic acid. And the positions of the carboxylic acids 1, 2, and 4. Now let's talk about a case in which there is a substituent attached. This substituent is hydroxy group. We'll start numbering from here 1, 2, 3, and 4. These carboxylic acids are not numbered. Remember this. Well, 1, 2, 3, 4. Hydroxy group is present in carbon number 1. We'll name it as 1-hydroxy. Then comes the 1/3 and 4. On position number 1, 3, and 4, they are carboxylic acids. And what is the chain? The chain is butane, so we'll name it as butane tricarboxylic acid. In order to understand the naming of derivatives of carboxylic acids, you can see the video of naming of derivatives of carboxylic acids on our channel. And in order to ask any question or any difficulties, you can comment down in the comment section and we will answer that. Thank you for watching, and please subscribe and like and share this channel. Thank you.